Hey, so I did the second video without this thing being on. Isn't that amazing? So now I found a way to turn this thing on and we're good. So you can see the lights now. I'm red, I'm good. Hopefully it is better than the other one. Yeah, it probably proves the point that I shouldn't have bought it, but don't believe that. Remember, I need it for gaming. So let's go back to our ANOVA there. Now we have example number three. And example number three, we have shift one, shift two, shift three again, product one, product two, but the numbers are different in the example number three. And here we run our ANOVA, and this is the result, right? So can I reject any one of those, hypothesis one or hypothesis two? Yes, I can. Which one is it? One or two? Number two, right? Because that is the sample. Remember, the sample are here, product one or product two. So are the rows, not the columns. And I can definitely reject it because my p-value is 0 and my threshold here is 0.17. The other ones are not different, right? And now we go to our games. How is going to chart going to look like, right? So look at p-value. I can reject the null. I can say that there's a significant difference between product one and product two. I can say that there's no significant difference between shift one, two, and three, and we're going to talk about the interaction later on. So let's go back to our game. How is that chart gonna look like, right? We know that there's no relationship. It is like this. We know that there's an impact and shift. I have shift one, two, three. So at least one of them will be very different. Products are similar. But now products are different, right? So go ahead. We have that game that we play, which is a very cool game. You can do that. For example, now we're approaching when we approach, the holidays. You can do that with your family and play the game. Say how to draw a chart when I have a two-way ANOVA that the sample is significant and the columns are not significant, and then people kind of play it and it'll be very fun. I can imagine that. So go ahead, take that piece of paper, draw it, and let's do the drums. Have you drawn it? It's gonna look like this, right? Well, it is two parallel lines. Why are they parallel like this? Because I know, right, that shift one to two and two to three, and then one to three, they're not different. So these lines are parallel like this, right? There's no difference between the shifts when comparing the columns. But I know that there is a difference between product one and product two. So they're farther away. So they were close together and overlapping when there's no significant difference between them. When they have a significant difference between the products, they go farther away, right? And there's a space between them. And that's the significance difference. And I know you guys got it right. Again, bring that to our class. I want to see those beautiful drawings. And we can see here what's going on, right? So we have the mean of product one being 29, the mean of product two being 58. So tell my manager here saying, okay, we have a big problem with the way that we build those products number two. All of them have a higher defect rate than our product one. So let's investigate what we're doing in terms of operation procedures, what the operators are doing, but they're basically doing the same bad thing in all shifts. In this one, our managerial implication when there's a problem with shift, it is not a problem with our standard operation procedures. That's probably something that the workers or the leaders are doing different in shift two, and let me say a lot different in shift three, and that's very common. Shift three is the one that we have less management and less people around. So a lot of problems happen in shift three, and we only find out in shift one in the next morning. Okay, so this is our example number three when we have a significance difference of product or a significance difference of sample. Let's see how that audio came through.